In this video, we are going to discuss about callbacks in Node.js. As you know, this is very common concepts. If you already know, you can skip this video. But in this video, we are going to discuss callbacks in detail, how it works under the hood in Node.js, in the memory also. So before diving into callbacks, we need to understand two concepts. That is synchronous programming and what is asynchronous programming. Now we will start with asynchronous programming. Suppose I have three tasks, okay, A, B, and C. Suppose A is a IO bound task, means it will require more time to finish, and B and C are normal tasks. So what it does is this A task is assigned in the background, and CPU will continue with B and C. Means it will not wait for A to finish; it will directly go to B and C, and the A will keep on working in the background. And when the background completes A task, the CPU will handle its result again. So what is the takeaway? That we are not going to wait for task A to complete. We will directly jump to B and C. We will finish those, and then whenever the A is completed in the background, then we'll display its result. Okay, this is called as asynchronous way. Now I'll give you one real life example. Okay, suppose I'm doing some work over here. Okay, I'm coding something. Now what I thought is I want to download some song. What I'll do, I'll go to the browser and I'll download some songs over here. Okay, what I'll do, will I wait for the complete song to download, then I'll jump to work, or I'll just make it download in the background and again I'll resume my work? Obviously I'll put this task into background, let it download in the background, and I'll jump to my work again, right? This is the asynchronous way. But what do you mean by synchronous way? Synchronous way means I am doing my work, and when I go to download thing, I'll wait till this complete download is finished, and when this download is finished, then again I'll resume my work. This is called as synchronous way. So this is the difference. In synchronous way, we wait for the IO bound process to complete and then we resume our next task. But in asynchronous way, we don't wait for IO bound process. We just assign it to background, let it complete in the background, and then we directly jump into the second tasks, right? So now we'll do some programming, basic file read and write operations, so we'll understand it more concisely. Okay, so suppose I'll make one directory, call back to cd. I'll make some function call.js. I'll create some uh, text file so that to read the text from this file. Okay, and so see, suppose this is the text file which I want to read. Okay, this is the IO operation, means I want to read this file. Okay, so suppose this is hello folks. Okay, now I'll write my code over here to read this file example.txt. Okay, so I'll load the module called file systems from built-in Node.js modules. Okay, okay, this will load into the heap memory. The object called fs will be stored into the heap memory, and this fs, which is a variable in which we are storing this reference of this object, means address of this object, this will be stored into the stack memory, means in my call stack. If you guys don't know call stack, I'll explain it in the different video. Please comment it out. Okay, so now console, start my script over here, start reading file. Okay, then I'll call a asynchronous function. Asynchronous function means IO function. Okay, with using this address, I will call read file function. I'll pass the file name which I need to read. This one. Okay, example.txt. I want to read this file, right? So that's why I'm passing this file name example.txt. Suppose its type is UTF-8. Okay, console.log reading file. Okay, and here, okay, and here again I will write console end of the script. Now what will happen? First it will load this file structure. Okay, in call stack the address of this object will be there, file system object, and then it will print this. It will go over here in console.log. It will print this. Now this is a IO bound process, so it will be assigned to the background, and again it will jump to this. So this will print out, this will print, this will print, and this will execute in the background. Okay, this will execute in the background, but how will I know that this is finished? I also want an alert that this reading file is done. So how I will do? I will add one alert. Means I will add one callback function. Suppose error data. So I need to understand that, oh, this read file is done. Okay, it's just simple. If else I'll add error error by reading file, and then else if there is a error I need to return else clg console the data file data. Now as we have written this into the else, we don't need this. Okay, so what I'll do, I'll pass one callback function, so it will inform us that, oh, this file reading is done, and this code I have written in this callback function. Okay, so now I'll run the program. So see what happens is it will go to read file. It will print this one. Then again it will assign this read file to background process, and it will jump to end of the script. So end of the script is printed, and once this read file function is finished in the background, the callback will return whatever the things we have written there to return. Okay, so this is how the callbacks works. Now in real life example I'll explain you what is callback. So as I gave you one example of working and downloading song, see, if I am doing some work and I'm downloading something from here, okay, and I'm resuming my work over here, so how will I know that, oh, that download is finished and I can listen the song? So I'll get some notifications, right? I'll get some alert that, oh, that background downloading song is finished, and then I can listen to it. So that notification, that alert is nothing but callback. So we pass one function to alert our system that, oh, this background process is finished and you can go ahead with it. Okay, so this is how I have passed here. This is the callback function. This is the alert which says the this read file function is completed, and you can use it. Okay, so this is your file data. So this is how callbacks works. Now we will understand how it works into the memory. Okay, we'll see how this will be working under the hood in the memory. Okay, so let me copy this and paste in. So what our JavaScript engine will do, it will execute the code step by step, right? So it will come first over here. So what does it mean? Fs equal const fs equals to require fs. Require fs is a function. What does this require fs will do? It will load the file system module, which is a Node.js built-in module. Okay, it will load this module into a memory. Okay, into the memory called as heap. And this object, as you know, JavaScript consider function as object, so this function will considered as object. say this is a function fs, this is considered as object, and it will be stored into the heap memory. Suppose its address is 200. Okay, it is stored in the location of 200. Okay, so what this fs will do, this fs will be stored into your call stack. Now what is call stack? Call stack is nothing but call stack uses stack memory to store the function and its execution context. Okay, so what does stack memory do? It uses stack data structure. So what is your stack data structure? Stack data structure means it will store first global things whatever is there, then it will store your next function. Suppose it is read file, then it is console like this, and it executes in LIFO manner, that is last in first out. So this will be executed first, then this will be executed, then this will be executed. So likewise, this call stack will be executed. Call stack will store all your functions and related execution context to execute the program. Now let's see our program step by step. Okay, so our program here, it will store fs in your call stack. So this fs will contain the address of this actual object which is loaded into the heap memory, this fs object. And this, what is its address? 200. So it will be stored over here in the call stack. Okay, so after this it will be stored into your global thing. Okay, so this global will be cleared out from the memory after the whole program is been executed. Okay, so now it will come to our next statement. Next statement is console log. Okay, what is console log? Start reading file. So here this will come console.log and it will print start reading. Okay, once this start reading file is printed, this will be clear out from the stack memory. Okay, so this will be cleared out. Okay, so it will again come to the next statement. What is our next statement? The next statement is our read file function, which is a IO function. So once it comes to the call stack, Node.js notices it that, oh, it's a async function. Okay, so what Node.js does is it assigns this function to libuv library, libuv. Okay, so what this libuv will do, it will take this read file from this call stack and it will assign this to threads. Okay, see, multi-threading is used everywhere. So these threads will execute your read file IO operation, IO thing, right? So this will execute this IO and it will register a callback as it contains some callback, right? So it will register a callback and it will, in the background, it will execute this read file and it will be moved out from the call stack. Okay, and it will be assigned to the thread which is running in the background, right? Now it will come to our next statement. What is our next statement? Our console.log. Again it will come to console.log, will come to the call stack and it will print end of the script, end of script. Okay, it will print it. As soon as it is printed, it will clear out from the call stack. Okay, so this will be cleared out from the call stack. Now as call stack is empty, so after this completion of this read file, so once this thread has completed the execution of this read file, the callback is registered in a queue. Okay, this callback is stored in a queue. That queue is called as callback queue. Okay, so once this thread completes its read file execution, it will store this callback into a callback queue. And as you know, event loop, what it does is it always checks the call stack whether it is empty or not. Once it notices that, oh, call stack is empty, it will push this callback from this callback queue to call stack for execution. So once this call stack is empty, event loop will push this callback from your callback queue to call stack, and here this callback will get executed. And once it gets executed, the call stack will be empty again. This global will also, as the program will end, it will also get cleared out. Okay, so what is the takeaway? The takeaway is your IO functions. This IO function, read file function, is being executed in the background using the threads. This libuv assigns this your IO function to threads and it is executed in the background. Meanwhile, the other functions, other normal functions in your call stack get executed, and once this is completed, it registers the callback in a queue called as callback queue. And once your event loop notices that your call stack is empty, your callback will be pushed from your callback queue to call stack, and here it will get executed, and once it is executed the program is completed, right? So the stack will get empty. Okay, and it will clear out the memory. So this is the takeaway. I hope you understand everything. If you don't understand, please comment. Thank you.